He is now in a PhD program, but his peers in the program are closer in age to his children than they are to him. And they call him Dad. Brutal. Please welcome Dusty.
Yes, I am in the Army. However, anything and everything I'm talking about today has nothing to do with the Army. You can see that the conversation is going to be about fantasy football. I think any colleague that I've ever had, past or present, knows that whatever organization I work for, I'm a part of, always has a fantasy football league going on. And that becomes the most important thing that we do in that agency, as my friend Robert reminded me earlier. So I'm excited to talk about this. Very grateful for the opportunity from Jared to do it. Hopefully, even if you're not a fantasy football or football fan, you can get something R-ish out of what we talk about. So as I mentioned, we're going to talk about three major things: the ESPN API to get our data, integer programming, which is how we're going to model, and also R. But before we do it, a short side note: I've taken up this hobby of anytime I go somewhere, I go for a run, and I usually try to make it in the shape of an R. So this is my DCR. It wasn't actually today. It was when I lived here recently. As you can tell, it's a hobby. I ran in an italics R at West Point. This one looks like my daughter drew it, and this one is in, it's off the screen, which makes me kind of sad. That was in New York City. Hopefully it's not the case for everything that I have. Just briefly, a little bit about my background. I'm a former engineer officer with tours to Iraq and Afghanistan. Spent some time now as an ORSA, Operations Research Systems Analyst at West Point as a faculty member, and previously at CAA. I'm currently in a PhD program at Baylor. Here's some action shots of me like typing on a computer, because that's what it seems like I do most of the time. Hanging off a tank here, an Iraqi tank, which I probably shouldn't have been doing. And here I am trying to pull a Humvee, which wasn't very successful at. I've got a lot of math-ish educational background, probably too much, mostly operations research. I went to The Ohio State, which is pretty cool. Go Buckeyes, and currently Baylor. My family, who mean the world to me. I show my wife, Jill. I refuse to put the M in Michigan, as most Buckeyes do, but that's where she's from. And I've got, a new family of Bears that we're really excited about it. But what I assume about you today is you may or may not know much about football, but that's okay if you don't. You don't need to know much. I'm assuming almost no knowledge of fantasy football, so I'm going to give a little bit of background on how this works so the math makes sense. And then maybe a little bit about integer programming, but it's okay if you don't have much knowledge about that either. And lastly, I assume quite a bit of knowledge of R stats. I'm going to show some code, but even if you don't know exactly what I'm doing, hopefully we can hang on. So let's talk about fantasy football. In summary, for those that aren't familiar, fantasy football, like most fantasy sports, you join a league of people, usually that you know, and you kind of select players that play in the National Football League, and based off their performance, you gain points for their performance. And every week you play head-to-head with another player, and if you score more points than your players score more points than who you're playing against, you win for that week. As you can see here, we encourage in the Baylor Stats Department league that I'm in to pick some pretty, mathy names. I'm the armchair quarterback. I beat Tidyverse Terry Tibbles. Oh, and I should also note before I go too far, you can see my record there. So I don't really know if you should trust me about winning fantasy football. I'm 2-9, so I probably shouldn't even have mentioned that. When you participate in this league, rosters have a certain makeup. As I show here, you have one quarterback, two running backs, two wide receivers, a tight end, another player, a defensive player, and a kicker. And you can see here the second win I had the year that I decided to show against the strong law of large victories, which is a fun pun off of the strong. I'm not even gonna go there because I'm not doing so well in theory right now in class. Now, to kick off the league, you have to select players. One of the traditional ways of selecting players is a snake draft, and that's where you all take turns in the league picking someone. But a more fun way to do it, I think, is an auction draft. What happens is someone nominates a player, and then everyone has $200 of fake money, and whoever's willing to spend the most money on that player gets them. But of course, the obvious cost if you spend a lot of money on a good player, you have less money on other players. And you continue bidding on players until your entire roster is filled out for every league. Now, there are a couple strategies as Drew Brees here is thinking about. One of them is you can just spin big on a couple players, and that's a technique, and it sometimes works well. You can spend $66 a piece, and you have $1 left for the rest of your team, but you have 3 good players. The other option is to try to get bargains throughout the draft, but that's risky as well. Maybe there's a more intelligent solution, which is where I want to introduce integer programming. With integer programming, what we're going to do to try to maximize the expected point production of our future team is we're going to make a few assumptions. One, we're going to assume that the players in the league, that we know how many points that they're going to make. There's all sorts of experts out there that are making these projections, so we're going to assume they're correct. Second, we're going to assume that we know the cost that we can get the player at in the auction. So with those two assumptions that we know aren't true, but we're gonna proceed with it. With those two assumptions, the goal is to maximize the expected points. And we have a number of constraints that we have to adhere to. One is we have only $200, right? And we also have to build out our roster according to the certain positions. Otherwise, I just get a bunch of quarterbacks because they score more points than anyone else. Another important information that I want to mention before we proceed is I'm going to assume that we don't care about our bench, meaning that we can just get whoever's left at the end for $0, which is fine. And secondly, I'm going to assume that we're indifferent to our defense and our kicker. And usually that's a pretty good assumption because their performance throughout the season is largely arbitrary. So don't waste money on them. Okay, getting a little mathy. The goal that we have here, I'm going to try to move my mouse around to point, is in the upper left-hand part. What we're trying to maximize is the points of player P or QRWT, which is their position person player indicator. And the X is a 0-1 indicator, meaning they're either on my team or not. And this is subject to, if they're a quarterback, running back, wide receiver, tight end. Now, if we just didn't have any constraints, we would just take every player and we would, run up a lot of points. But as Lee Corso says every Saturday, not so fast, my friend. We have some constraints that we have to adhere to. And among those are the positional constraints, like how many are on our team. We get 1 quarterback. So across all the quarterbacks, which I can't even point well. I wish I had a really long pole. Across all the quarterbacks, we can only have 1. It is possible to have up to 3 running backs if one of them is this extra position, this flex that we have down here, which is equal to 6, because those are, the running back, wide receiver, tight ends. You can have up to 6, but no more than 3 running backs, no more than 2 tight ends. And we also have the last financial constraint, which is that every player on our team has to sum to $200 or less. And given those constraints, we can proceed forward. But one of the things that I think is more interesting about this is how we actually get the data, right? Because we could just spend a lot of time and create a list of how much we think everyone's going to be. But the really fun part is that ESPN has an API. And there's a niche community on Reddit who's done a lot of work to try to hack into this API. They don't publish any information about it. Hopefully they don't turn it off. But I found about the API originally, if anyone's got any experience with this, by spying on the browser in Chrome, you can watch all the APIs that it hits up when you load a page. So I found this API, which has this base of a URL, and you can see it hitting up the fantasy football data, which is known as Kona player info for some reason. And I've posted all this code online. I'll give you the link to that later. But the problem I had is when you run this code as is, you only get 50 players, and there's way more than 50 players that you're interested in, which is where I had to rely on the Reddit community. I appreciate those folks. There's this block of code that sends a header in the request saying, hey, send me more than 50 players, and I've requested 500 here. Afterwards, it comes in a not very readable format. You have to turn it into a JSON. That's how you say it. Hopefully I'm saying it right. And then we have to pick that file apart to get the data. I know there's more eloquent ways to do this, but the way I did it was I just started reaching down into this nested data frame, this nested file, selecting out fantasy points, what season it is, the scoring period ID, which doesn't make much sense right now. But when you see the data in a second, you will. And then do a little bit of cleaning to get the exact row of that player you want, get the right season, still filter for the maximum fantasy points for the season because it also gives weekly expectations. There's a lot going on here. So I built a function to do one of them. And I decided to pluck out one player in particular. I know one of Jared's favorite players is Stephon Diggs, but he's one of the higher predicted fantasy football players that exist. And I think you have Jared maybe to credit for him being on the Vikings for a little while. But here's an example of one output, but we create a function to get one output. We can now map that one using per over all the fantasy football players. And we end up with a, well, we also need to clean that one up a little bit too. It takes a lot of cleaning because you got to identify their positions and all sorts of things. But once you download and clean all that data, now you have the expected fantasy points for each player. And I show the top 10 from each position. Hopefully these names look familiar and they should look like they're pretty good. I'll also note now that every time I run this code and render the presentation, it goes out and hits the ESPN API and pulls the most recent season predictions. So the reason these are all predicted to do well is because they've already been doing well. At the beginning of the season, it had a few other players on here that were ranked quite a bit differently. But I think that's kind of a feature and not a bug. Now, let's get down to business of actually modeling. In R, there's a number of integer programming or linear programming functions. And us at CAA have used a number of these to do some modeling. Maybe I'll talk about that at the end. But the one I'm most familiar with, and I wish I knew some of these others better, is LP solve. Some of these other ones you can use more of like notational syntax, but this one you have to build out your matrices and all the fun things. So let's talk about how to do a model with LP solve. First, you got to give it your objective equation. So this FOBJ, the objective function, fantasy objective equation that I've got there, is a whole bunch of ones and zeros. Oh no, it's a whole bunch of points. Like how many points does each player have? The second one is the constraint matrix. So what are their positions? Like it's a bunch of zeros and ones, like are you a quarterback? Are you a running back? So on and so forth. And the last row is the expected point value, which I kind of overlooked, but ESPN also projects how much you should spend on that player if you want them on your team. I completely blew past that earlier. I should note that now. And then we build the like is equal to directional vector, which you can see here. See here, here. And then I can scroll a little bit and you put, you know, is equal to 1, is equal to less than or equal to 3. And then that, then I wanted to show you as well, like what these look like, even though this is like enough to make your eyes bleed with like code and vector numbers. That's just terrible. But to actually get the solution, you run the LP function. And in the LP function, you tell it the direction, which we want to maximize points. You know, what's our objective function? What is our matrix? You can see each one of the arguments that you provide. And then lastly, you designate that it's all binary because you can't have like a fractional Tom Brady, which as much as I think he's great, he's probably a fractional Tom Brady as is. I hope he doesn't hear that you say that. I think he's great. Okay. And this is what our solution looks like. A bunch of ones and zeros. You should notice there's enough ones to fill a fantasy football team. So here's your answer, go win your league, right? You can't do much with this. So let's take it back and clean up the results a little bit. Find who actually these ones and zeros belong to and put them on our team. Now, if you're a football fan or a fantasy football fan or anything, I hope that you feel that this would be a pretty darn good team if you were able to get all these people in your league, right? Like this would probably win every week. But as I mentioned before, every time I run the code, it re-updates everything. But the thing I want to mention is when you go into your fantasy draft, and here was the mistake I made the first year I did this. I went in, I had, you know, my list of players, but all of a sudden I want to spend $18 on Josh Allen, but somebody's willing to go like $50 on him. I'm like, no, the math says $18 and that's it. Like, I'm not spending any more than $18. And then that completely messes up like everything. If I spend more than it, I don't have the same like best team. So there's certainly a challenge to overcome. And that's what I want to talk about for a second here is what happens if things don't go as planned. Well, let's see if I can do this live. I don't have this hosted. I need my mouse back. Oh no, there it is. All right, got some code here. This is dangerous, y'all. Dashboard. Run document. They're gonna work. Nice. Well, not nice. Hold on. I don't know why, but sometimes I have to go here and change it like this. And it works the next time. I don't know why. And if it doesn't work like this, I change it back and it works next time. There we go. Look at that. So here's the team that I should get, right? It should look familiar. We saw it a second ago. I want Josh Allen, doggone it, but I'm unwilling to go over more than $18. So I built this application to go in, and I really wish I was mirrored right now. Somebody else got Josh Allen. My O key doesn't work. There he is, Josh Allen. And now it removes him from the data and reruns my integer program and tells me who the new best, most points, likely to score points fantasy football team is. And you can keep iterating through this if you lose players. And then as you say, I do get, I don't know. Who's my running back up there? Is that Josh Jacobs? I like all the Joshes, I guess. Well, are we going to work? There we go. Then he comes off the board. And I also provide a little bit of functionality that if I had to, well, this is going well. There we go. If I had to go over, I can like make adjustments. Like if I went a dollar or two over, I can adjust this, and all of a sudden you see it changing my team because I don't have as much money as before. I still lost this year, so if nothing else, it helps you make a more informed decision when you go into it. I think that's what we find a lot in our jobs is that we have all the analysis. A lot of times it's not the right answer, but if you didn't even have something to like go down that road, you'd just be completely lost. So I'd rather operate with something like this in my back pocket than anything else. And my final thoughts here. What I would love is if somebody out here was like super passionate as well about this and had time. I've got this repo hosted with everything. Please fork it, update it, make it better. Maybe we can all win our fantasy leagues together, like our powers combined. Super Jared in his like our costume. Jared wore his costume, so I had to wear mine as well. I appreciate it. Thanks everyone for the time. Look forward to chatting with you afterwards. Thank you.